Okay, so in this lecture we shall start the problem solving sessions on alternating current. Okay, so let's discuss that. Alternating current. Alternating current. Okay, so look at the first problem. A 20 ohm resistor, 1.5 Henry inductor and 35 microfarad capacitor are connected in series with a 220 volt 50 hertz supply. Okay, so here try to write the given information over there. The given that we have a resistance R as 20 ohm, and after that they have given the inductor of inductance L is equal to 1.5 Henry, and the capacitance of capacitor C is equal to 35 microfarad. Okay, so it must be is equal to 35 into 10 to the power of minus 6 farad, because micro in the sense 10 to the power of minus 6, correct? So and this is connected to a voltage supply. So let me take this is the RMS voltage. So RMS must be is equal to 220 volt, and the frequency F is equal to 50 hertz. Okay, so this is the given information over there. So the question is to find out the impedance of the circuit. So Z is equal to how much, and calculate the impedance of the circuit and also find the current flowing through the circuit. See, we need to find out the IRMS. What is the value of IRMS here? Okay, so this is what the question is. So clearly we know that to find out since this is the RLC circuit or LCR circuit, so to get the impedance we have the simple formula Z is equal to square root of R square plus XL minus XC the whole square. Okay, so it's not compulsory that XL minus XC, it might be XC minus XL also. So we need to find out Z here. This is what the impedance of the circuit. They have given the value of R, but we don't know what is the value of XL and XC. So try to find out XL and XC. That is what? Inductive reactance and capacitive reactance. Okay, so to find out XL, what I do is XL is equal to 2 pi FL, correct? So therefore I can say that this is what 2 into 3.142, the value of pi, and the frequency is how much? Frequency is 50 hertz is given, and inductance L is 1.5 Henry. So 1.5 Henry. Okay, take a calculator and solve this expression. Suppose if you solve that, you will get XL is equal to 471.3. Okay, 471.3 ohm. Okay, so this is what inductive reactance. Similarly, we know that capacitive reactance XC is equal to 1 divided by 2 pi FC. Okay, so this is equal to 1 divided by 2 into 3.142 into F is 50 into how much? C is 35 micro. 35 into 10 to the power of minus 6. Okay, so at that time if you solve this expression, 1 by 2 into 3.142 into 50 into 35 micro, you will get it around 90.9 ohm. Okay, so you will get it around 90.9 ohm. Okay, so this is what capacitive reactance. So now try to substitute the values in impedance Z. Z is equal to R square. R square is 20 square now. This is 20 square R square plus XL minus XC. This is what? 471.3. 471.3 minus XC is 90.9. The whole square. Okay. Suppose if you solve this, you will get it around square root of 20 square is 400, as you already know it, and 471 minus 90.9 will give you this is 144,707, correct? 704.16. If you solve this, you will get the final answer as 381 ohm. Okay, so 381 ohm. Okay, so this is how you need to solve the problem for impedance Z here. Okay, so the second question is, what is the value of the current flowing through the circuit? Okay, so current flowing through the circuit in the sense IRMS you need to find out. We know that I is equal to V by R, correct? So V by R in the sense, so instead of R in the normal DC circuits, we need to take Vrms. It implies Irms must be is equal to Vrms divided by, instead of resistance we need to take the impedance, because impedance is the total resistance offered by the circuit. So that's the reason why Vrms divided by Z. Okay, so Vrms is how much now? Vrms is 220 divided by 381. Okay, 381. So this will give you 0.58 ampere. 0.58 ampere. So this is the solution for the current flowing through the given circuit. Okay, so this is how you need to solve this problem. Look at the next problem. So the second problem. The second problem says that a sinusoidal voltage of peak value 285 volt is applied to a series LCR circuit in which the resistor of resistance 5 ohm, inductor of inductance 28.5 millihenry, and the capacitor of capacitance 800 microfarad are connected. Okay, find the resonant frequency. The question is to find out the resonant frequency. Okay, so let's try to do this. A simple problem as we solved as the last example as it is. Okay, so try to write the given information first. Please try to write the given information first so that you can easily solve this problem. Okay, so this is given that peak value of voltage is given. Peak value in the sense V naught, correct? So V naught must be peak value, correct? Vrms as well as and peak value, that is what V naught. We represent it by V naught. So V naught is equal to 285 volt is given, 285 volt, and applied to the LCR circuit in which the resistor of resistance R is equal to 5 ohm. Okay, so inductor of inductance is given, L is equal to 28.5 millihenry is given, and the capacitance of capacitor, okay, so capacitance of the capacitor C is equal to 800 micro, 800 into 10 to the power of minus 6 farad. Okay, so find out the resonant frequency. Okay, resonant frequency in the sense you need to calculate either omega. Okay, so let's try to find out the value of omega here so that you can easily find out, and also calculate the impedance, current as well as power dissipated. Okay, power dissipated. So here let's try to find out the resonant frequency. F is equal to 1 divided by 2 pi into root LC. Okay, 1 divided by 2 pi into root LC. This is what the formula to find out the resonant frequency here. Or else we can say that, so F is equal to 1 divided by 2 into 3.142 into square root of L into C. So L is 28.5 milli in the sense 10 to the power of minus 3 into C is how much? 800 micro 10 to the power of minus 6. Okay, so solve for it. Suppose if you solve this, you will get F as 33.33. okay, F as 33.33 hertz. Okay, so it's nothing wrong if you calculate omega as well. Okay, so you can also find out the omega, because we know that omega is equal to 1 divided by root LC. This is also possible, but the changes radians per second. Okay, the unit changes radians per second. You can also solve this by using omega as well. Okay, no worries for this. Now we got the resonant frequency of as 33.33 hertz now. So the second question is calculate the impedance, current dissipated at the resonance. Okay, the condition is given at the resonance. Okay, so try to use that condition. Suppose the condition is given as the circuit is in resonance condition. So at that time we have to use this expression Z is equal to R. The total impedance of the circuit must be is equal to the resistance included in that particular circuit. Okay, so that's the reason why this is what actually happens in the case of resonance. Okay, so the question is to find out the impedance. So impedance Z is equal to R. Z is equal to R in the sense what? Impedance Z is equal to how much? 5 ohm. Directly we can say it as Z is equal to 5 ohm. Okay, the second question is what is the current? So current in the sense they have given the peak voltage here. They have given the peak voltage. Suppose if the peak voltage is given, at that time we need to calculate the peak current. I naught is equal to V naught divided by Z. Okay, V naught divided by Z. So V naught is how much? V naught is 285, Z is 5. So 5 is 5 3s are right. So how much is that? Suppose if you take the calculator and if you solve for it, you will get 57 ampere. Okay, 57 ampere is the maximum current flowing through that circuit at resonance. Okay, so third question given is power dissipated. So we know that power dissipated P is equal to, okay, so to find out the power dissipated, we must know that power P naught must be is equal to V naught I naught cos pi. Okay, power P naught is equal to V naught I naught cos pi, but the value of pi is going to be how much at resonance? Must be is equal to 0 degree, correct or not? So it must be is equal to 0 degree at resonance, because they are in the same phase. So that's the reason why it must be I naught and both are in the same phase. So at that time only we'll get the resonance condition. So that's the reason why pi is equal to 0 degree. Suppose if I take the pi is equal to 0 degree, what will I get? P is equal to V naught into I naught. So V naught is how much? V naught is 285 volt, 285 volt, and I naught is how much? I naught is 57 ampere. So 57 ampere. Suppose if you solve this, you will get the power displayed as 16 to 45 watts. Okay, so this is how you can calculate the value of power dissipated, okay, by using the simple formula P is equal to Vi cos pi. Okay, so the next problem, move to the next problem. A source of alternating EMF 220 volt 50 hertz is connected in series with a resistance of 200 ohm and inductance of 100 millihenry and the capacitance of 30 microfarad. Does the current lead or lag the voltage by what angle is the question. This is of March 2017 question. The good question asked. Okay. See here now, try to write the given information. So EMF, so they have given VRMS. Okay, the value of VRMS is 220 volt, and then the frequency is how much? 50 hertz. The frequency is 50 hertz, is connected in series with a resistance of 200. R is equal to 200 ohm. R is equal to 200 ohm, and the inductance L is equal to how much? 100 millihenry is equal to 100 into 10 to the power of minus 3 henry. And after that, capacitance C is equal to how much? Capacitance C is equal to 30 microfarad. That is what? 30 into 10 to the power of minus 6 farad. Okay, so the question is to find out, does the current lead or lag the voltage by how much angle is the question, correct? So to get that, we know that whether the current is leading or lagging. It's a simple trick. I will tell you that. First of all, you need to find out the inductive reactance as well as the capacitive reactance. Okay, the first step is you need to calculate capacitive reactance or the inductive reactance. Okay, so after that, compare both the values of inductive reactance as well as the capacitive reactance. Suppose the capacitive reactance is greater than the inductive reactance, at that times current leads the voltage by pi angle. Okay, so we know that how to find out. Tan pi is equal to XL minus X divided by R. So this is a simple formula which you need to use to get the value of pi angle, correct? So the phase angle. So let's try to find out the XL and XC now. So as I already said, so XL is equal to 2 pi FL, correct? 2 pi FL. So 2 into 3.142 into F is how much? F is 50 hertz into L is how much? L is 100 millihenry. L is 100 millihenry, correct? L is 100 millihenry. Try to do that now. L is 100 millihenry. So correct. So L is 100 milli. 100 into 10 to the power of minus 3. Okay, so at that time, if you solve this by using your calculator, you will get XL as 31.4 ohm. Okay, 31.4 ohm. Okay, so similarly, try to get the value of XC. XC is equal to 1 divided by 2 pi FC. If I substitute the values, you will get 1 divided by 2 into 3.142 into 50 into capacitance is how much? 30 micro. So 30 into 10 to the power of minus 6. Okay, so you'll get XC as 106.1 ohm. Okay, so now compare XC and XL, correct? So clearly you can say that XC is greater than what? XL, correct or not? Because XC is how much? 106 and XL is equal to how much? 31.4. Clearly XC is greater than XL. Suppose if XC is greater than XL, at that time what I said? Current leads the voltage. So but to get the angle, phase angle, we must use the formula that tan pi is equal to XC minus XL divided by R. Okay, so therefore pi is equal to tan inverse of, substitute the values, XC is how much? 106.1 minus XL is how much? 31.4 divided by R is how much? R is 200 ohm. Okay, so that must be is equal to, at that time you will get pi is equal to how much you will get here? Pi is equal to 20.5 ohm degree. Okay, 20.5 degree. Use the clerk table to get this angle. Okay, so pi is equal to 20.5 degree you will get here. So therefore we can say that current leads the voltage. Current leads the voltage by 20.5 degree. So this is how you need to solve this problem. Okay, look at one more problem. So an inductor and a bulb connected in series to a AC source. Okay, so try to write the given information so that you can easily solve the problem there. Try to write the given information. Please write given. What is given? AC source Vrms is given. Vrms is equal to how much? Vrms is equal to 220 volt. Okay, so 220 volt and frequency is equal to how much? 50 hertz is equal to 50 hertz is given. Okay, so current of 11 ampere. So clearly it must be IRMS. IRMS must be is equal to how much? 50 ampere. Is 11 ampere is given. 11 ampere. Okay, current of 11 ampere flows to circuit. 11 ampere. Okay, circuit, and the phase angle between the voltage and current is pi by 4 radian. Okay, so pi is equal to pi by 4 radians. Okay, so the calculate the impedance and inductance of the circuit is the question, correct? So you know that this is the simple, which one? Inductor and bulb, correct? So it in the sense it is L and R circuit or LR circuit or RL circuit. Okay, RL circuit, in the sense capacitance must be is equal to 0. Okay, we know that Z is equal to square root of how much? Z is equal to R square plus XL minus XC the whole square. But here XC, see, capacitance is absent, correct? So that's the reason why the impedance Z is equal to square root of how much? R square plus XL square, simple, XL square. Okay, so now try to get the value of, we need to calculate the value of impedance. That's what the target now. So we need to calculate the impedance and inductance of the circuit. That is what the formal problem. Okay, so to get the impedance, I just use the information that they have given, Vrms and IRMS, because we know that impedance Z is equal to what? Using the Ohm's law. Okay, Vrms divided by IRMS. This is a simple formula I will use to get the value of impedance, because Vrms is given, IRMS is given. So Z is equal to Vrms is how much now? Vrms is 220 volt divided by IRMS is 11, in the sense 20 ohm. Okay, so 20 ohm. So now if it is 20 ohm, so at that time I will go to what? To find out the value of L now, correct? So let me take one more value, that is what? R, but we don't know what is the value of R. So for that I use cos pi is equal to R by Z. This is the formula. I hope that you remember this, correct or not? Cos pi is equal to R by Z. Suppose if I use this one, so we have cos pi by 4 radian, correct? This is what cos pi by 4, this is pi, phase angle is pi by 4 equal to R divided by Z is 20 ohm. Okay, so therefore I will get R as how much? Cos pi by 4 is 1 by root 2. So I will get R as 14.14 ohm. 14.14 ohm. Okay, 14.14 ohm I will get here. Okay, suppose if I get R value, then it is very easy to calculate the value of Z, L now, correct? So let me use that now. So let me say how to do that. I will square on both sides. Okay, I will make it square on both the sides by using this equation. Let me rewrite it again. Okay, so we know that Z is equal to square root of R square plus XL square. Okay, so let me square on both sides. I will get Z square is equal to R square plus XL square. Okay, so therefore I will get XL square is equal to Z square minus R square. Okay, so Z is how much now? Z is given as 20 square minus R square, that is what, 14.14 this square. Okay, so this is what, 400 minus 14.14 square, in the sense we will get around 200 it seems. Yes, exactly, it is 200. Try to do it by using calculator. Actually it is 14, yes, it is 200, nearly equal to 200. So I will get around 200. So therefore I can say that XL is equal to square root of 200. Square root of 200 is 14.14 again. So 14.14 again, correct, exactly, it is correct. So now it's very easy to calculate the value of L. It's very easy to calculate the L. Use that. XL is equal to 2 pi FL. XL is equal to 2 pi FL. So therefore I can say L is equal to XL divided by 2 pi F. So XL is given as how much? 14.14 divided by 2 into 3.142 into F is 50. Okay, suppose if you substitute the given values and if you take the calculator and if you solve for it, you will get L is equal to 45 millihenry. 45 millihenry. This is how you need to solve this problem for XL as well as L here. Okay, we shall continue.